Hello everyone, I am Karan Masru. Welcome to this video. In this video, we are going to look at the solution of the problem, that is binary tree to CDLL. First of all, let us start by understanding the question. What does question say? Given a binary tree of n edges, the task is to convert this to a circularly doubly linked list. Okay, so we know the doubly linked list means each node will point to the next node and to the previous node, and it is also circular in nature. Okay, so the last node will also point to the first node and first node will point to the last node. The left and right pointers in the nodes to be used as previous and next pointers respectively in circularly doubly linked list. So we are given a binary tree. Right now in binary tree, each node will have two pointers, one is to the left child and one is to the right child. So we can use these two pointers as the previous pointers and the next pointers of circularly doubly linked list. Okay, so we can convert that structure of binary tree itself into a circularly doubly linked list. Okay, the order of nodes in circularly doubly linked list must be same as in order of the given binary tree. Okay, so what should be the order of the nodes of the binary tree in the doubly linked list? It should be the in order traversal of binary tree. The first node of the in order traversal, leftmost node in binary tree, must be the head node of the circular doubly linked list. Okay, so if we look at this example, so what will be the in order traversal? What is in order traversal of binary tree? Left subtree, then current root, then right subtree. Okay, so this will be the first, this will be the second, and this will be the third. So this would be from head to tail, and this would be from tail to head. Okay, 2 1 3. Okay, so this would be the doubly linked list 3 1 2 in that form, and 2 will also be connected to 3 because it is circularly doubly. Okay, and here see, first 40 will come, then 20 will come, then 60, then 10, and then 30. That is the in order traversal of binary tree. So our doubly linked list will be 40 20 60 10 and 30. 40 will be connected to 20 and 30. 20 will be connected, 20's next pointer will be connected to 60, and previous pointer will be connected to 40, and so on. Okay, you don't have to take input or print anything. Complete the function b tree to c list that takes root as a parameter and returns the head of the linked list. Okay, the driver code prints the linked list twice, first in the right order and another time in the reverse order. We do not have to take care about that. We just need to convert the binary tree into the circular doubly linked list, and it will return it in this order. Okay, it will print the driver code, and the constraints are given here. The expected time complexity is big O of n and expected auxiliary space is big O of h, where h is the height of the tree. So now if we think about solving this problem, then first of all let us say that this is the given binary tree and we want to convert it into a circular doubly linked list. Now here what they have said is, we can see what will be the structure of this binary tree. Each node will have a data point or a value. Each node will have a data or value. Each will have a left pointer to the left child, and each will have a right pointer to the right child. So we will keep the data or value as it is. Left pointer can be used as a previous pointer in a doubly linked list, and right pointer can be used as a next pointer in a doubly linked list. Okay, we want to convert this into circular doubly linked list. Okay, and the order in this circular doubly linked list would be the in order of this binary tree. Now to understand here, see what is the in order traversal of binary tree. In order traversal is traversing the left subtree first, then the current root, and then the right subtree. Okay, now theoretically, if whenever you want to find the in order traversal of a particular binary tree, what is the easiest way? You mark on the bottom of all the nodes, and you start from here and you mark a path in this way. Okay, through the circumference of this tree, and you go from here to here, and whenever you encounter this sign, you take that node in the in order. Okay, so what will be the in order of this? So here I started traversing from here. Here when I came, I encountered this mark. Okay, so 40 will be the first one. Then when I went up, I encountered this mark, so 20. Then I will come here, I will encounter this mark, so 50. Then I will encounter this mark, so 10. So 50, 10. Then I will encounter this mark, so 30, and then I will encounter this mark, so 60. So the in order traversal is this. So what should be the output? In the output I should get, this is 40, this is 20, this is 50, this is 10, this is 30, this is 60. Okay, and it is a doubly linked list, so there will be a previous pointer also. So the previous pointers will be in this way, and it is circularly doubly linked list. Okay, so it is circular in nature. So the previous pointer of the first node will point to this, and the next pointer of this node will point to this. Okay, so this should be my output, and here we can use the left and right pointer of the binary tree for the next with respect to next and previous pointers of the nodes to convert it into a circularly double A linked list. So what I can do here is, see, one way is to store the in-order traversal of this binary tree in a, let's say, vector or array, then make a complete circularly double A linked list. But for that we need to make new nodes, and here it is said that you do not need to make new nodes. Use the left and right pointers of the binary tree nodes as the previous and next pointers of the circularly linked list respectively. Okay, so what I can do is, I can traverse this tree in order. Okay, so left subtree, then the current root, and then the right subtree. At every point of time, I will keep two pointers. One is the previous pointer and one is the current pointer. Okay, at every point of time, I will keep two pointers, previous and current. Previous pointer will be pointing to the previous node in the in-order traversal, and the current pointer will be pointing to the current node in the in-order traversal. For example, let's say I am at 50, so my current pointer will be here and my previous pointer will be at 20. When I will go at 10, my current pointer will be here and my previous pointer will come here. Okay, so at every step of time, I will have two pointers, previous and current, and at every step I will say current left is equals to previous and previous right is equals to current. Now why am I doing so? Because the left and right pointer in circularly double A linked list will work as next pointer and previous pointer respectively. So for example, here 20 has this left pointer and right pointer. That left pointer in 20, this is the left pointer of 20, it will work as the previous pointer pointing to 40, and the right pointer will point to 50. It will work as the next pointer of circularly double A linked list. Okay, so this is my idea, and whatever be the first node in the in-order traversal, that will be my head. Okay, so I'll start the in-order traversal from here, and initially my current will be equal to previous, will be equal to null, and my head pointer will also be equal to null. Okay, so what is the in-order traversal? Left subtree, then root, then right subtree. So this is my root. I'll call the in-order traversal here. I'll go on the left subtree. Now there is a still left subtree on the left part, so I'll still go on the left subtree. Now there is no left subtree, so this is the first node in the in-order traversal. So let's say the pointer to this node is t. So I will say that if head is null, then head is equals to t. If head is null, then this is the first node in the in-order traversal, right? So head is equals to t and current is equals to previous is equals to t. When will I do this? If head, if let me put the if statement here. If head is null, then I will do this. If head is not null, then what I will do? I will say previous right is equals to current and current left is equals to previous. Okay, now when I encountered this for the first time, I said that my head pointer is pointing towards this and my current and previous are also equal to t. So what I will get is, I will get 40, my head pointer will be pointing here, and my current and my previous pointer are also pointing to this. Now I will backtrack from here. Okay, I will go to 20. When I will go to 20, so before moving on to 20, I will say my previous is equals to 40. Okay, because when I will go here, before moving on to that, my previous will remain current only. When I will go here, this will become my current node. So this will be my equal to current node. We will also look at the implementation, so things will be clear. Okay, don't worry about that now. So this became my current node. Now head is not null. See, when head was null, when we encountered the first node in the in-order traversal, we said head equals to t, current equals to previous equal to t, and we got this. Now when we came here, our current node became equal to 20 and our previous node is this 40. Okay, now head is not null, so we said previous right is equals to current, or and current left is equals to previous. So this is my previous, my current is what, 20. So I said previous write is equals to current. Now my current is 20. Okay, it is somewhere here. I said previous write is equals to current and current left is equals to previous. Okay, so this became like this. Now I will go here, but before I go there, I will say previous is equals to current. Okay, and then I will, so basically then I will call on the right subtree. So first of all, I'll call on the left subtree, then I will operate on the current root, and then I will call on the right subtree. Okay, so first of all, I will call recursively on the left subtree, then I will operate on the current node, and then I will recursively call on the right subtree. But before I call on the right subtree, so my current node will become this. For this, previous will be this. So I will update my previous to this. So my previous will come from year to year. Okay, and my current will come to 50. So this will also go, and my 50, and this will become my current. Now is head empty? Is head null? No. So previous right equals to current and current left equals to previous. Previous right equals to current, current left equals to previous. Similarly, then I'll go backtracking here, then I'll go backtrack and here. Now this will become my current node, and this will become my previous node, right? Because at the last step I will be here, right? And again I will say that current left is previous and previous right is current. So similarly, then 10 will be added, then 30 will be added, and then 60 will be added. At the end, after I complete this process, I will finally, my head pointer will be here, and at the last step my previous pointer will be here. Why? Right? Because previous pointer was first here, then it came here, then it came here, then it came here, then it came here, and then it came here. So after the complete in order traversal, I will say that my head left is equals to previous. So my head left will be equal to previous, and my previous right will be equal to head. So my previous right will be equal to head, so that it also forms the circle. Okay, now let's look at its actual implementation. So if we look at the actual implementation, so I have taken 2 pointers, head and previous is equals to null, and I have this is the function which we have to complete, in which we have been given the root node. So I have called the in order traversal on the root node. Now if we look at the in order function, so this is here I have passed the pointer current. Okay, so better understanding. Now if current is null, then return. If the current there is no node, then return. Otherwise, what is the in order traversal? First left subtree, then operate on the current node, then right subtree. So first of all, call the in order function recursively on the left subtree. Then if the head is null, it means this is the first node in the in order traversal, then head equals to previous equals to current, that is this current value. Okay, else previous right equals to current and current left equals to previous, so that it forms a doubly linked list. And before going on to the right subtree, we will say previous equals to current, because when I'm going to the right subtree, let's say this is 2, this is 1, and this is 3. So when I'm going from year to year, at present my current is this and my previous is this. Now when I say in order current right, so the next current will become this. Okay, this will become the next current, that is current right. But for that, the previous node in the in order traversal is this, right? So before calling that, we just update previous as current. Okay, so in this way the doubly linked list will be formed, and at the end, after completing this in order traversal, I will say head left is previous and previous right is head to form the circle. What will be the time complexity? We are visiting all the edges once or all the nodes once, so I can say big O of n. And what would be the auxiliary space? So the auxiliary space occupied here will be nothing but the call stack, which will be used to store the data of the recursive functions of this in order traversal. So how many recursive calls will be made on the call stack? It will be equal to big O of h, that is nothing but the height of the binary tree. At max, this many calls will be stored in the call stack. Now let's submit this code. So let's submit it. So we have solved this question successfully. I hope you have understood the solution completely. Thank you.